Yeah, thank you for the kind introduction. Honorable Shri Ajay Bhatt and other dignitaries on the dais and participant of this 4th MET and 14th HTS conference. What I'm going to talk about today is advances in materials, power and energy technologies for Atmanirbhar Bharat. And I'm going to give you my perspective on this whole issue. This will be a very fast-paced presentation with a visual overload. So listen to my story, look at the title and the tagline, and you'll get the essence of what I'm saying. This is a standard disclaimer from my lawyer. It essentially says the views I'm going to present are my personal views and no way reflect Reliance Industries' forward strategy. Important government of India initiatives, some of them are related to here for Atmanirbhar Bharat, Make in India for defense equipment, infrastructure projects, clean energy, and essentially this is going to take us from about $3 trillion economy today to about 10 trillion by 2030. So what I'm going to talk about is primarily related to the 4th Industrial Revolution. We're at the cusp of 4th Industrial Revolution, and it's really amalgamation of physical, digital, and biological words. So it is not just about digital, where India has made tremendous progress, but most importantly, it is integration of biological technologies with the physical and the biological, along with the digital technologies. So some of the technologies are also critical for defense, which are listed on the left-hand side of this chart. So this relates to, and it has a wide range of impact on society and economy at large, as shown on the right-hand side of this chart. And so as you know, these are the critical technologies for defense. For example, drones and cyber and biological warfare are now new dimensions compared to the conventional warfare. Artificial intelligence, additive manufacturing, and new materials, along with clean and green energy, will become very, very important. Let me be blunt. India missed all 3 previous industrial revolutions. So this is our opportunity to capitalize on the 4th Industrial Revolution and help our economy grow at a much faster pace. So this is really a great opportunity for us, and mainly because the velocity of disruptions with new inventions, and let me repeat, inventions, and accelerated innovation are hard to comprehend, and so we need to be agile. So let me begin. And if you look at the material evolution historically, this is how it has happened. But in the modern civilization, it's really the steel, polymer, silicon, and now carbon age is what's important. I just use plastics and our consumption per capita as a surrogate. But as our economies grows, all materials related to modern civilization will grow. And this is really a great opportunity. So let me give you my perspective on some of the advanced materials in defense. Carbon fiber composites and ceramic composites will become important, as well as, for example, 3D printed direct metal laser melting, which is also shaping ground. So there are a lot of advanced materials which are critical for military modernization. But what I'm going to talk about is really about advanced materials for the future soldier. And there's a lot of stuff on that, but essentially it's going to be where he has a display, a very lightweight armor. He's going to have biosensors and communication technology that's going to make him aware of the entire battlefield, and very precision, for example, rifles in his hand. And many defense technologies have civilian applications at the end of the day. So I'm going to talk about the armor and our DPE, a novel engineering polymer that we have developed and invented here in India. And we are making a lot of different defense products, like for example, bulletproof vests. And our product is far better than the materials available from our competitors from abroad, like Dyneema and Spectra. We've been working with DRDO and other labs to demonstrate and actually validate our products. This is a significantly lighter bulletproof material than what's available on the market, and we also shown it for armor for vehicles, if you will. So many of our products are shown here, and this is something I'm really excited about. This is invented in India, and then we're making in India. We're building a commercial plant in Baroda to take this technology, not just for defense, because there are many civilian applications as well. So now let me talk about the other big area we're working on. It's really a carbon fiber polymer composites. and we are in the process of creating India's largest integrated carbon materials plant. So it includes carbon fiber, graphene, nanotubes, carbon wraps. In fact, carbon wrap is something you can see in our booth outside. And most importantly, we are integrating downstream into composites, intermediates, and finished products. Certainly this business is going to grow because of emphasis not only for defense but also for many civil applications, especially in the renewable energy area, because lightweighting with the carbon fiber is going to be a key in terms of composites. And so we are going to differentiate through our scale and ability to integrate. That will bring the cost down and that will expand the market very, very fast. So let me talk about how defense industry has actually helped, and just give you an example of, for example, the Boeing 787 Dreamliner. If you look at it, it was really DARPA, US DARPA, which made huge investments in many advanced materials, which are at the top of this chart. And certainly, after about 10 to 20 years, these materials become available for civil applications. It wouldn't have happened if it was not for DARPA making investment. Keep in mind, the new materials development needs long-term commitment, and it needs fairly large amount of capital involved in this. So DRDO has a similar opportunity, and I'm actually appealing to Dr. Kamath here, to spearhead Indian inventions innovation ecosystem by putting investments in variety of areas. You may not know this, but DARPA was the first one to make investments in mRNA technology, which actually ultimately resulted in these mRNA-based vaccines, which you're quite familiar with. And mRNA will play a critical role, a biological technology for cancer treatment, if you will. And I'm going to be fast-paced because some of the materials that we have developed, because infrastructure is going to be another big driver for Indian economy to grow. So some of our products are listed here, and some of these are displayed in our booth as well. Some of these I'm not going to talk in great detail because you can talk to people in our booth. Now the other big area is really green, clean energy, and certainly Indian government has made many initiatives which are related to, and again I'm not going to go into details, but Indian government is incentivizing solar, wind, batteries, so on and so forth, biofuels. And certainly if you look at the Prime Minister Modi's appeal in Amrit Kal, as we talk about, these are the technologies that are going to help India become self-reliant on energy while we are decarbonizing our economy at the same time. And as Mr. Goyal said up front, we're not only going to be making equipment here for our own use, but we will be big on exporting it to the world for green energy as well. And Reliance is doing its own part in this. And there are many things that are on this list that Mukesh Ambani has talked about in public domain. We're putting a lot of investment in solar PV, in batteries, in fuel cells, green hydrogen through electrolysis. We're also partnering and bringing some best technology from startups from abroad, and those partnerships are at the top. And so Reliance, the main competitiveness that we have is that whatever we build, we look at end-to-end manufacturing. So we start from all the way from the beginning to the finished product. So you'll see more about that. But what I'm going to talk about in my talk today is what we are doing in Reliance within R&D, if you will. So related to solar, we are looking at a lot of these new materials like perovskites and graphene conducting films and quantum dots, and making composites. And the whole idea is that can we make these materials cheaper and improve the efficiency. Now I'll go and talk a little bit about hydrogen, because everybody's talking about hydrogen. And certainly the hydrogen is applicable to many industries to decarbonize. They're listed on the top left. Probably you cannot see it. But new invention we have made is actually about catalytically, keep in mind, a solid catalysis to, for example, convert biomass to green hydrogen. And most importantly, the way we do it, our capex is 40% lower than the rest of the world in terms of gasification, and so is our opex. And the key point here is that the hydrogen that we will make from biomass is at the same cost as what we make today from steam methane reforming or hydrocarbons. It's a major breakthrough, if you think, and is invented here in India. The other thing I'll point out is that the same technology can be applied for gasifying our high ash coals, and this is something we can also exploit. Since I talked about the fourth industrial revolution, importance of biology, let me talk about how biology is going to impact in converting CO2 the carbon dioxide, the greenhouse gas, into all kinds of things. I'll talk about the green oil and ability to convert waste to wealth a little later, but let me focus on how are we converting carbon dioxide to materials like leather, nanofibers, and I'll just give you one example of a spider silk so you'll get feel for what I'm talking about. And this is all about using CRISPR technology or genetically modifying organisms to essentially take a feedstock like CO2 and convert to various things. And this is going to be the future